principle of dynamics. Let's go back to that. So we have first the definition and characteristics of translation, the rectilinear motion with constant acceleration and free-falling bodies. And today, what we're going to discuss is this one, no, rectilinear motion with variable acceleration. So in rectilinear motion with variable acceleration, we have actually 5 cases to consider, but we have two major cases, or the first 2 cases that we have to understand. First, in case 1, the displacement is given in terms of time, or S is equal to a function of time to find V and A. So to understand that, we have this example given the relationship that S equals to 5t plus 4t cubed, S is being in feet and t is equal to in seconds. We are asked to determine the velocity and acceleration after 3 seconds. So let's have this one. S is equal to, given for to us, that 5t plus 4t cubed. Okay, so from that, we know that the velocity is the derivative of displacement with respect to time. So velocity will be equal to 5 plus 12t squared. And we know that acceleration is equal to the first derivative of velocity with respect to time. So that is equal to 24t, no? Coming from here, 5 plus 12t squared. So applying, no, that t is equal to 3 seconds given to us in the problem. So therefore, velocity is equal to 5 plus 12 multiplied by 3 squared. V is equal to 113 feet per second, and acceleration is equal to 24 multiplied by 3, and acceleration is equal to 72 feet per second squared. And so this is our answers in terms of our equation in case number 1. Okay, so dali, because we just have to remember that velocity is equal to the derivative of the displacement with respect to time, and acceleration is the derivative of the velocity with respect to time. Okay, so how about case number 2? In case number 2, if in case number 1, displacement is the function of time, in case number 2, acceleration with the function of time, to find the velocity and displacement. Okay, so for us to understand this one, given the relationship A is equal to 2t, A being in feet per second squared and t in seconds, okay, so it is known that S equals to 4 feet and V is equal to 2 feet per second when t is 1 second. So we have a given displacement and velocity with respect to time, okay, with respect to a known time. Whereas to determine the velocity and the distance, okay, from this acceleration equation, that is for case number 2. To solve that, no, we have to use, or we have to remember, we have to remember in from case 1 that dv is equal to dt. So therefore, dv is equal to a dt. And we have this equation, a is equal to 2t. Okay? So substituting, dv is equal to 2t dt. So we have to integrate this one. So the velocity given to us, that is 2 feet per second, where time t is 1 second. That is, the limit is 2 to v and 1 to t. Okay, 1 second to t. So therefore, it will become what? This will become v minus 2 is equal to t squared minus t squared. Okay? Tama ba? T squared minus t squared, where t is equal to 1 minus 1. Okay, to simplify further, that this will be equal to v is equal to t squared plus 1. Okay, kasi nilipat na sa kabila. So that is for our first equation. So now, we know also that v is equal to ds over dt. Okay? Therefore, ds is equal to v dt. And we have this v. Okay? Given we solve it, no? So that is ds is equal to t squared plus 1 dt. Okay? So we're asked to integrate this one. Okay, what is the displacement? That is from 4 feet, no? 4 feet siya if time t is 1 second. So therefore, it will become s minus 4. Tama? S minus 4 is equal to t cubed over 3 plus t minus 1/3 minus 1. So to simplify further, s equals to t cubed over 3 plus t plus 8 over 3. This is our second equation. Okay, we have the equation of displacement and the equation of the velocity. So given that we have both equations, so let's rewrite it on this part. So v is equal to t squared plus 1 and displacement is equal to t cubed over 3 plus t plus 8 over 3. So when t is equal to if t is equal to 2 seconds, so we have this v is equal to what? 2 squared plus 1. V is equal to 5 feet per second. And displacement when t is equal to 2 seconds, s is equal to 2 cubed over 3 plus 2 plus 8 over 3. S is equal to 7.33 feet. So these are the answers to our problem because we are asked now when t, or should I say given the determine the velocity and distance. So let's assume that is in 2 seconds. So these are the answers. If it is in 3, we are going to substitute time to 3 seconds. Okay? So that is for case number 2. Case 3, on the other hand, is a combination of both. Okay? It's a combination of case 1 and case 2 wherein the velocity is given in terms of the function of time. Okay? V is equal to function of time to find A and S. Kanina, we are finding or in case 1, displacement in terms of time and in case 2, acceleration in terms of time. This time, velocity in case 3 with respect to time. So it is a combination of case 1 and case 2, differentiating the given velocity time relation and the acceleration will be determined by while integrating the uh, displacement formula. So that is ds is equal to v dt. Okay? So that is for case number 3. So now we will proceed to other cases. So we have this case 4 wherein one of the principal variables is expressed in terms of an adjacent variable. So kung kanina we have this acceleration with respect to time and velocity with respect to time in case number 3. So in case 4, acceleration in respect to the velocity and velocity with respect to displacement. Okay? So we're going to use the cases 1 to 3 in solving case 4. Kumbaga, it's a combination of 3 cases uh, working hand in hand with the equation. Okay, so it's either you integrate or differentiate whatever it is or substitute the exact value given on the problem or how the problem to you was presented. Okay, so in case 5, we have that the variables are not adjacent. No, so A is equal to what? With respect to displacement. So hindi siya, kumbaga, there's no adjacency. No, hindi siya adjacent to each other. So we could solve that by substituting the relationship BD is equal to ADS, no, from the first topic that we have, and then proceed with case 4, and then followed by 3 cases because case 4 is a combination of 3 cases. Okay, so for us to understand these cases from cases 1 to 5, let's solve some sample problems. Okay, so problem number 8. So we're done with problem 1 to 7, and 7 is your seat work. I still remember that. So problem number 8 here is the motion of a particle is given by the equation s equals to 2t raised to 4 minus t cubed over 6 plus 2t squared. Okay, s is in feet and t is in seconds. Compute the value of v and s when v and a when t is equal to 2 seconds. Okay, so first that we are asked to compute the velocity. Yan. Velocity after 2 seconds. So given the equation, s is equals to 2t raised to 4 minus t cubed over 6 plus 2t squared. So we have that. We know that the velocity is the derivative of displacement with respect to time, no? From the uh, cases 1 to 3 or in case 4. So that is 8 t cubed minus t squared over 2. Why t squared over 2? Nangyari kasi is what? This will become 3t squared over 6. Okay, so 3 over 6 is 1 half or t squared over 2 plus 4t. Okay, so when t is equal to 2 seconds, so velocity now is equal to 8 multiplied by 2 cubed minus 2 squared over 2, okay, plus 4 multiplied by 2. So V now is equal to 70 feet per second. And this is our answer for the first known or unknown in the problem. Okay, the velocity after 2 seconds. Now for the second one, we are asked for the acceleration. Acceleration when after 2 seconds. Okay, so we know that the acceleration is what? The first derivative of the velocity. And velocity is equal to 8t cubed minus t squared over 2 plus 40. So given that principle, so let's take the derivative. So this will become 24t squared minus t plus 4. Okay, substituting t is equal to 2 seconds. A now is equal to 24 multiplied by 2 squared minus 2 plus 4. A is equal to 98 feet per second squared. So this is our answer in problem number 8. Okay, in terms of its acceleration. Okay, so ginamit natin both the acceleration with respect to time and velocity with respect to time given we have this equation s with the function of time. Okay, case number 1. Okay, in next problem, let's read. Particle moves in a straight line according to the law s equals t cubed minus 40t, where s is in feet and t is in seconds. The first item that we need to answer is when t is equal to 5 seconds, compute for the velocity. Second, find the average velocity during the fourth second. So that means there's two velocities that we need to find so that we could have their average. And C, when the particle again comes to rest, what is acceleration? So from the given word rest, that means the velocity is equal to 0. So to answer, let's have this letter A first, wherein we are asked to solve the velocity after 5 seconds. Sabi dito, velocity after 5 seconds. So we have this formula, s equals to t cubed minus 40t given to us. Okay, velocity is what? You know that v is equal to ds over dt. So that is 3t squared minus 40. So v is equal to 3t squared minus 40. When t is equal up to 5 seconds, 3 multiplied by 5 squared minus 40, v is equal to 75 minus 40 or 35 feet per second. So this is our answer to letter A. So we just use case number 1. Okay. So in letter B, we are asked to find for the average velocity during the fourth second. So let's average velocity during the fourth second. So that means in between that after 3 seconds and after 4 seconds. Okay. So first let's find the velocity after 4 seconds. Okay. So we're going to compute that. So let's still use the velocity equation. V is equal to 3t squared. So this time it is v sub 4 minus 40. So this substituting after 4 seconds, 3 times 4 squared minus 40, this is equal to 8 feet per second. So, velocity after 3 seconds because it is during, no? During the 4th second hinahanap natin. So, let's find after 3 seconds. That is the start of the 4th second. Tama? So, V sub 3 is equal to 3t squared minus 40. After 3 seconds, 3 squared minus 40, or it will give us a negative value of negative 13 feet per second. So, to find the average, no, that is equal to V sub 4 plus V sub 3 over 2 or equal to 8 plus negative 13 over 2, it will give us the value of what? This will become 5, negative 5 over 2. This is negative 2.5 feet per second. Okay? So this is our answer to this problem. Negative 2.5 feet per second. The average velocity during the 4th second. Sabihin, nangyayari. Okay? So, we have the first one, velocity after the 5 seconds, and the average velocity during the 4th. And last, we have the acceleration, letter C. We have this one, letter C. The acceleration when the particle comes to rest. Okay? So kanina we have this notion that if the particle comes to rest, the velocity will be equal to 0, right? So what is the velocity formula? 3t squared minus 40. So equating to 0, 0 is equal to 3t squared minus 40. We have the value of time that is equal to square root of 40 over 3. So let's remain it as it is, no, so that we are not rounding off numbers in between calculation. Okay? So, how about the formula of acceleration, by the way? Acceleration, so remember that this is the first derivative of the velocity with respect to time. Okay, that is equal to, kung ito ay 3t squared minus 40, this will be equal to 6t. So, substituting, a is equal to 6 multiplied by square root of 40 over 3. Acceleration will be equal to 21.909 feet per second squared. So this is our answer in the last problem. Okay, so let's consider that if it comes to rest, the velocity is equal to 0. Okay, so that is our answer to that problem. Okay, problem number 9. Okay, so now let's proceed with problem number 10. In problem number 10, there's a ladder of length L moves with its ends in contact with the vertical wall and the horizontal floor. If the ladder starts from the vertical position, its lower end A moves along with the floor with a constant velocity V sub A. Show that the velocity of its upper end is V sub B is equal to negative V sub A tangent theta, where theta is the angle between the ladder and the wall. What does the minus sign mean? Is it physically possible for the upper end B to remain in contact with the wall throughout the entire motion? Okay, so let's have this illustration. Okay, we are asked in the problem to prove that the velocity of this point in point B is negative V sub A tangent theta. So the first one is let's prove it. So to prove that, no, let's use Pythagorean theorem. So since the wall is in what? Let's assume that it is in right triangle position. So L squared is equal to x squared plus y squared. Let's integrate these variables. And we know that the length is in a constant value. Okay? Length is in a constant value, so it will become 0. So the equation will become 0 is equal to 2x dx over what? What are you integrating? The velocity, no? Plus 2y dy over dt. So simplifying this further, 2x dx over dt is equal to negative 2y dy over dt, right? So we could cancel 2 here, okay? Okay, we could cancel 2. Okay, so now let's simplify in terms of their what? In terms of dx over dt. dx over dt is equal to what will be the answer? dx over dt is equal to dx over dt multiplied by what? Negative x over y is equal to dy over dt. Or we have this one, no? So we know that from this triangle, no, dx over dt is this one, no? So if magmo-move, malamang pa ganito siya. So we could answer the concept of the minus sign. Why? Because it moves leftward. That means the velocity is leftward. So, and then this velocity is what? Let's assume that it will be on downward motion to point B. So therefore, your dx over dt here is the v sub a, right? And the dy over dt is v sub b. So, and then theta here, okay? Theta comes from tangent theta, it's right triangle, opposite of adjacent, x over y. Tama ba? So therefore, dx over dt is v sub a multiplied by tangent theta. dy over dt is v sub b. So let's rearrange this. It will become v sub b negative v sub a tangent theta. So we already proved that the velocity at point B is negative v sub a tangent theta. Now, the next question, is it physically possible for the in the point of the ladder will remain contact as it moves, no? Or continues in motion, no? So it is physically possible because the motion will stop once point P reaches the floor. Kapag sumayad na siya doon sa sahig, doon pa lang mag-i-stop. But it will remain in contact with the wall. Okay? So, the answer is yes, it is physically possible. No? Posible po, no, na it will remain in contact with the wall. Okay? So, that is the answer for problem number 10. Okay? So, in problem number 9, or 11 rather, let's move with this second to the last problem. So it states here that the velocity of a particle moving along the x-axis is defined by v is equal to x cubed minus 4x squared plus 6x, where v is in feet per second and x is in feet. Compute the value of the acceleration when x equals to 2 feet. Okay, so we have to compute first the acceleration when x is equal to 2 feet. No? So, tinanong natin. So, alam natin, no, what's the equation? V is equal to x cubed minus 4x squared plus 6x. So, V, okay, V is equal to 3 multiplied by 2, okay, minus 4 multiplied by 2 squared plus 6 multiplied by 2. Velocity is 4 feet per second. Okay, we have this, no, 4 feet per second for the velocity. Why is it that we compute for the velocity? Because we know that the acceleration is dv over dt. And applying the equation, that will become 3x squared minus 8x plus 6 dx over dt. We know that dx over dt is a velocity. No? This is the velocity of the moving particle. So, continue the process. So, A is equal to 3 multiplied by 2 squared minus 8 multiplied by 2 plus 6 multiplied by, what is V? 4 feet per second. A is equal to 8 feet per second squared. So, this is our answer for the acceleration. Now, we are asked to find, no, the acceleration lang, no, value of the acceleration when t is equal to 7. So yun lang, no. So we just computed for the velocity because we don't have any value of the acceleration yet, no. But we have given the equation of the velocity, and we know the relationship of the velocity with respect to time, that is the acceleration. Okay, so and now let's proceed to the last problem. The last problem states here that the motion of a particle is defined, okay, by the relation A is equal to 40, where A is for uh, where A is in feet per second squared and T is in second. It is known that that S is equals to 1 feet and V is equal to 2 feet per second when T is equal to 1 second. What we are asked here is determine the relations between V and T, S and T, and V and S. Okay. So first, let's have the relationship between V and T. Okay. So we have this formula, acceleration is equal to 4t. And we know acceleration is dv over dt. So 4t. So dv is equal to 4t dt. So let's integrate this one. What from 2 to v given to us, no? Velocity is 2 feet per second and time is in 1 second. So applying the integration, it will become v minus 2 is equal to 2t squared minus 2. So pwede natin makancel yung 2 from the right side and left side. So v is equal to 2t squared. So this is the relationship between v and t. Okay? So for the relationship between s and t, so we know that v is equal to, balikan natin, yung equation na 2t squared. And v, we know that this is ds over dt is equal to 2t squared. So ds is equal to t squared dt. So what are the limits that we're going to use for this integration? S given to us as from 1 feet to s and time is 1 to t. So s minus 1 is equal to 2/3 t cubed minus 2/3. So 3s is equal to 2t cubed plus 1. So this is the relationship between what? Between the S and T. And last is the relationship between V and S. So from the first equation or first relationship, okay, V is equal to 2t squared, we could define time in terms of the velocity, that is V raised to V over 2 raised to 1/2. Okay? And then substitute it to second equation or second relationship. 3s equals to 2t cubed plus 1. So 3s equals to 2 multiplied by v over 2 raised to 1/2 multiplied by, or should I say, raised to 3 plus 1. Therefore, we could have the value of the velocity v raised to 3 over 2 is equal to 3s minus 1, okay, multiplied by square root of 2. Okay? Multiplied by square root of 2. And this is the answer for last relationship. Okay? So that's the problem number 2. So we've used cases 1 to 5, or should I say 1 to 4 here, so that we could, or 1 to 3, or let's say 1 to 4, so that we could arrive with different relationships with respect to the given value of the acceleration. Okay? So that's the end of our discussion in rectilinear motion with variable acceleration.